So we've looked at how to calculate moles from mass of solids, and now we're going to move on to how you would calculate moles if you were working with solutions. So when you're working with solutions, what you'll need to know in order to calculate moles is both the volume of a solution that you're using, and that must be in the units decimeters cubed, and then its concentration in moles per decimeter cubed. So if we would think about how we say that out, we're going to say moles per decimeter cubed. So we're going to talk about the moles per decimeter cubed. And that's why our volume needs to be in the units decimeter cubed. Now looking at the way we write per decimeter cubed, just notice that the per part is given by the little minus sign before the 3. So decimeters cubed for volume doesn't have that minus because that is just decimeters cubed, but because we're saying per decimeter cubed, then we've got this little minus sign. So what do we mean by a decimeter cubed? So if we imagine a cube, a decimeter cubed would be 1 decimeter by 1 decimeter by 1 decimeter. And the volume inside that cube would be 1 times 1 times 1, or 1 decimeter cubed. That's a 1 decimeter cubed, but what is a decimeter? Well, you might remember from maths that dec means 10, so 1 decimeter is 10 centimetres. So this cube is 10 centimetres by 10 centimetres by 10 centimetres, or 1,000 centimetres cubed. So 1 decimeter cubed is equal to 1,000 centimetres cubed. And that's very important in chemistry because you're going to be measuring volumes quite often in centimetres cubed. Remember that a small beaker holds about 50 centimetres cubed and a larger beaker holds about 250 centimetres cubed. So we're normally going to be working in centimetres cubed. So knowing how to convert from centimetres cubed to decimeters cubed is going to be very important. That's what a decimeter cubed is, and the unit of concentration is how many moles are there in this decimeter cubed. So if something is more concentrated, there will be more particles of it inside the cube. So if you're counting, we're not actually counting when we say 5 moles per decimeter cubed, that doesn't mean there's 5 particles, that means there's 5 times 6.02 times 10 to the 23 particles, but we're counting how many particles are per decimeter cubed. So in 1,000 centimetres cubed, how much actual chemical have we got comparative to the water? So let's just make sure we understand how to convert. So if we're given our volume in centimetres cubed, we're going to need it in decimeters cubed. So given that there are 1,000 centimetres cubed in a decimeter cubed, we would need to be times 10 to the minus 3. We'd need to divide by 1,000 to get centimetres cubed into decimeters cubed. But if we had decimeters cubed, we would times by 1,000, or 10 to the 3, to turn that into centimetres cubed. We could add on there, if we were given the volume, say, of a lake, it might be in meters cubed. And to get from decimeters cubed to meters cubed, it would be another times 10 to the minus 3, or back the other way, another 1,000. Because there would be, in a meter cubed, 100 by 100 by 100 centimetres, or 1,000,000 centimetres cubed. So if we wanted to go all the way from here to here, we would have to times by 1,000,000. And equally, if we wanted to go all the way from centimetres to metres, we'd have to divide by 1,000,000. So how do we calculate number of moles of these solutions then? Well, number of moles, remember we're giving the symbol N for number of moles, is volume, which we're going to give the symbol V, in decimeters cubed. Remember that's our really important little thing because concentration, C, is in moles per decimeter cubed. So if we put that into one of our triangles, we could see that moles our volume times concentration, or you might want to say to yourself to help you remember, moles are very clever. Moles are very clever. Let's have a go and then you can practice. So calculate the number of moles of hydrochloric acid. So number of moles of HCl. So I'm writing down which thing I'm calculating moles of, so that if I have multiple ones in a calculation I'll be able to know which one belongs to which. Volume times concentration, moles are very clever. And we need to think about where our volume is. So we go to our question and we find the volume. Now it's here, but it's being given in centimetres cubed rather than in decimeters cubed. Put that in yellow highlighter because I highlighted volume in yellow at the top. We've been given our concentration in 0.2 moles per decimetre cubed. So we can't combine these two because one's got per decimetre cubed and one's in centimetres cubed. We need to convert to decimetres cubed. So we're going to put our volume, 25, and then our conversion factor, divide by 1000 or times 10 to the minus 3, and then we're going to times it by our concentration. And we're going to work out our answer for that. So we get our calculator out, type that into our calculator, and see that the answer for that calculation is 5.0. And I'm going to give my answer to three significant figures because the numbers were given to three significant figures, times 10 to the minus 3 moles. Why don't you have a go and see if you can answer the next question? So numerically, if you just put the numbers in, its volume will be moles divided by concentration. So I've put the number of moles in, I've put the concentration, and I've got a numerical answer. Now if I left it like this in the exam, I would not score the mark because what units is my volume in? Now given that my moles were in moles and my concentration was in moles per decimetre cubed, this is now going to be in decimetres cubed. Make sure there's no little minus now, because it's not per, it's just decimetres cubed, this unit. Now if I asked you in an experiment to measure that out, you might struggle a little bit because most of the equipment has a scale in centimetres cubed. So what is that in centimetres cubed? Well, we would need to times by 1000, and we'd find that it was 400 centimetres cubed. Either of those numbers would be marked right in the exam as long as it had the correct unit with it. So the final little thing we're going to look at in this section is how that might be a bit more useful in chemistry. You're going to combine it with your mass calculation. So a sort of question you might come across is that you've dissolved a certain mass of a solid in a certain volume of water in order to create a solution. And you're being asked to find what the concentration of that solution is. So to work out concentration, we might be thinking, well, to get a concentration we're going to do moles divided by volume, but we haven't got moles, we've got a mass of a solid. And so the first thing that we're going to be able to do is turn that mass into a number of moles. And if we remember that mass is Mr. Moles, we can work out that moles is mass over mR. So we're going to need the mR. So let's add up the mR. So pause the video and add up the mR of sodium hydroxide. So using the periodic table you should have got 40. And then let's calculate the number of moles. So mass over mR, so 8 grams divided by 40, the mR, 40 grams for every mole. And we've only got 8 grams, so we don't have a whole mole. How much do we have? So type that in your calculator and work it out. 8 is a fifth of 40, so 0.2 moles. A unit on. And so now I've got moles, and I want to work out concentration, so I can remember my other triangle. Moles are very clever. Concentration is moles over volume. But our volume is in the wrong unit. Remember that concentration is in moles per decimetre cubed, so we're going to need to convert to decimetres cubed. We're going to do times 10 to the minus 3. And then we type that into our calculator and we should get 0.8 moles per, and the per, remember, is that minus sign, decimeters cubed. So pause the video and see if you can calculate the mass of sodium chloride that would be needed to make this volume and concentration of solution. And if you've done that correctly, you should get 0.73 grams. So practicing calculations with solutions is really important as well, so maybe go away and have a look at some of the questions that you can find and see if you can calculate moles of solutions.